Okay. In the past, we already done for bipolar transistor. And in that bipolar transistor, we get an amplifier. And they get a common admitter, common base. Okay. Let's see. Admitter, common base, common collector. If you understand those amplifiers, they're not a big problem for JFET amplifier. They will be almost the same, okay? Just a minor difference. First thing, JFET a common use to amplify small AC signal, okay? And one reason for using JFET instead bipolar transistor is that very high impedance, okay? G can be octet. That's a big difference, okay? However, a big disadvantage, however, is that the voltage gain AV of enable with a JFET is much smaller. That's a big difference, okay? JFET amplifier configuration are as follows. First thing, you get a common source. Next will be a common gate. And last one is common drain. The same thing like bipolar. Okay. Common admitter, common collector, common base. Okay. If you get any question, just let me know. Now, let's go over the same like bipolar for AC. Okay. For AC analysis, okay, you get a 4-step. Even for bipolar or JFET, same thing. First thing, set on DC source to 0. Okay? That means you not see any DC voltage source in AC. That means they will be routed and replace them by short circuitry equivalent. Okay? Replace all capacitor by a short circuit. Okay? You can see the capacitor in the circuitry. However, when you're working on AC, the capacitor will be shorted. Okay? Remove all elements bypass by short circuit. Okay? Resolve the network in a more convenient and logical form. So if you already get through the bipolar, This will be the same thing. Now, you can see this is the AC. Okay? You can see this is the gate, this is the source, and this is the drain. Okay? So, that's the inside. You see, this is the inside. JFET. That means from the drain go into the source, you get the source current here. The value will be Gm times VGS. And this is the internal resistance. We're not supposed to be using that. So that one will be no longer here. Okay? The reason is if you get a load, that resistor is too big. Okay? So that's why they just draw it for you. However, when we do a calculation, we will ignore that internal resistor. Okay? JFET impedance equal infinity of FET output impedance Z0 equal. That's what they're talking about, that one here. Okay? We don't care that. Where IOS is a component of an admittance equivalent circuit. Normal has a ramp, okay, 10 to 50 microcycle. Okay, you can see this is the common source. Only thing is, when you're looking into the circuitry, I need you to recognize there will be a common source or there will be a common gate or common drain. Okay? Common source input apply to the gate, output from the drain. Okay? Now, we already get through the basic DC. Okay? How many DC for JFET? Mr. Smith, Tell me. You understand for the DC, you get a fixed bias and what else? Cell bias. Then,
It's a self-bias because of the battery, right?
yeah, this is a fixed bias. The thing that they using the battery here. The second one will be cell bias. And the last one we know, voltage divider bias. That at least, minimum thing you have to know. By looking into the circuitry, you know which one, how to solve the problem. We not design the bias, so we don't care. But basically, technicians, we have to know which one. Okay? So, for this circuitry, they're using fixed bias. You get the VGG. Okay? And then the next one will be C, input impedance and the output impedance. Input impedance, that means if you're looking into the gate, okay, what impedance? That's what they call input impedance. And from the output, looking into the amplifier, they're telling you output impedance. Okay, input signal applied to the gate, output taken from the rate. Okay,
Mr. Pham,
yeah,
so the input impedance would be RG, correct? Because you got to short out the battery.
right,
And then the
right,
output impedance would be you got to short out C2, and there's no other resistors, so it would be RD.
perfect.
Okay, thank you.
Okay, now input supply signal applied to the gate. Okay, this is the input here. Output taken from the drain. Okay, input output are out of phase. This was the same like common admitter in the bipolar. Okay, okay, now they draw completely AC. This is the VE. And now you don't see the capacitor anymore. They will be shorted. Okay? And you get RG. No more power supply. Okay, in here. The thingy power supply will be shorted to the ground. Okay? And now you can see from the drain, they get only the golden short. Go to the gate, and the value will be Gm times VGF. No more internal resistance. So up in here. Okay. At the output, okay, if you get the output, you can see this one will be grounded. So from the drain to the ground, you get RD. So that's why you get RD right here. And they already telling you battery VDD must be replaced by the short circuit. That means they go to the ground. And you don't have any capacitor in here. They will be shorted. Okay? So if I'm looking for input impedance, V in here, from the V in, looking into the amplifier, you get only one RG resistor. So input impedance will be RG. Output impedance, that means from the output you're looking into the amplifier, you see only one RD. Okay? So in this circuitry, very simple. Okay? When you're looking into common source amplifier, okay, try to understand everything we just talked to you. Okay? If you get any questions, just let me know. Okay. Any question up to this point? If not, now go to C. So you know that is the gate. This is the drain and the source here. Okay? And that's what they talking to you. Calculate the gain. Okay? So V out equal minus GM VGS times RD. You know why minus? V out will be measured from the drain to the valve, and the current will be opposite. So that's why. Okay? You take the current times resistor. Okay? So this is the formula. Okay? Minus GM times VGS. This is the VGS, the current here. Okay? Times RL or RD in this case. So VGS equal VE. The thing is VGS, that means from G to the S. That's the VGS here. Same thing VE. Okay? VGS equal VE. Then V out equal minus GM times VI times RD. And the AV voltage gain equal V out divide to V in. Okay? And that will be equal minus GM times RD. If the load including 10, okay, AV equal V out over V in minus GM times RD parallel load. In this case, we don't have a load, okay? So that's why they time RD only. So normally, to me, you don't have to memorize the formula, okay? But you try to understand the circuit. This is an example. For the fixed bias configuration of head and operating point defined by VGSQ, they given to you, okay? And IDQ, they given the voltage and they given the ID with IDSF equal 10 milliamp and VGS off equal minus 8 volt. The value of GM0 is provide 40 microsiemens. Okay. Now, see what they want. They want GM. You know the formula, right? GM equal, I think GM0 times 1 minus VGS over VGS off. Okay. And they want the input impedance, G in. You already know. G in now will be 1 mega ohm. G out. G out will be what the value, Mr. Smith?
I'm looking at it. It's going to take me a while. I haven't done this in a while, so hold on.
Who knows? See, on that one, we don't have a load. You only get 2K ohm connect to route. The thing at 20 volt will be routed. So,
So
out.
it's just 2K then, right?
Right. 2K, that means output impedance.
Yeah, because you short out C2.
For sure. You have to sort it out. You see that in here. Okay. You can get only 2K. And if you want the voltage gain, okay, then you can go into here, the voltage gain, AV minus GM times RD. And we don't care about number E, okay? They're talking about internal resistance. Okay, we don't care about that. That's a very, very basic minimum. You have to know how to do it. Even they could given you the formula. Okay? This is a drawing for that circuit. However, remember, we don't care that. Okay? So that's why Z out, you see, you get RD only. Z in, you get RG. Okay? Okay, now, there's a little more common source. They adding a lot. Okay? And for the DC, what the type of the DC? Trick bias, cell bias, voltage divider bias. Which one?
Self bias.
Cell bias. Okay? That's what I want you to understand when you're looking into the circuitry. And for cell bias, in order to solve it, for DC, you need the graphic, and normally for technicians, okay, they're not using graphic, they're not giving out. So that's why they given you one thing. That's what they given.
So 1 volt for the source.
Right. 1 volt VS. They must be given to something else. Okay? In order for cell bias. Otherwise, they have to given you the graphic, but that's not happen. So now, if they given to you a VS 1 volt, can you calculate the IS? VS divide. Correct?
Oh, yeah.
Okay, now,
1 volt divided by
yeah,
RS.
1 volt divide 200 ohm. And then another thing you must know, for the JFET, all the time, IS and ID will be
The same.
same thing. If you know IS, you know ID. If you know ID, you know IS. Okay? And can you tell me what output impedance?
Well, the output impedance is RD in parallel with RL, and
Perfect.
and then the C out is shorted out.
Right. G out. R D parallel. RL.
And for that to happen, you have to remember that C out is shorted.
Yeah, for sure. We're already talking about that. AC module. Capacitor will be shorted.
Short.
Okay. Input impedance. You get V in.
So you have to short CN,
For sure.
and then
That's shorted.
you get 1 meg
Right.
because it's high input impedance.
All right. That's what I only think I want you when you're looking into the circuitry, you're able to identify. You don't have to do calculation, but I need to you guys understand it. Okay? And later on, you can see the capacitor here. Same thing like common admitter in the bipolar. That's a bypass, right?
Right.
Bypass capacitor.
So, Mr. Pham, when you
Yeah.
bypass the CS, um, then that's like you got a wire going from that black dot on top to the one on the bottom. So is that like ground?
Yeah, that means they bypass RF.
So it's grounded.
Right.
Okay. And then also too, on the signals, the one after the gate and the one after the drain, what is it that where the phase is shifted?
What do you mean?
Okay, that you got two sine waves on there. One go one way, the other one go the other way.
Oh, you're talking about input.
Yeah, and the output.
We're already talking about at the beginning.
Okay, but
Common
can you
source,
repeat that again?
common source amplifier. Input and output 180 degrees
Okay, yeah.
out of phase. Okay?
Yeah, got it.
So this is a summary of common source. G in equal RG right here. G out equal RD if not R and they ignore internal resistance of the JFET. So you see that very simple. And the gate, okay, AV equal minus GM times RD. We're not using that internal resistance. So you can ignore that.
Because it's too high.
Yeah. Very simple thing. If you get RD, 1K, R small d, 10K. If they parallel, then you can get 1 times 10 divide 1 plus 10. 10 divide 11. So that's very close to 1K. Okay? So that's why we don't care about RD. Finally, common source amplifier has 180-degree phase shift between input and output. Okay? This is just the example. Okay? What they given to you, the thing they on this circuitry, they using cell bias. We don't need the graphic. That's why they have to give it to you. V in, Vs, 1 volt. Okay? And in this case, okay, you can get a load. So now you can see they want to calculate the VGS Q. Okay? IDQ, VD, GM0, GM, voltage gain, AV, input impedance, G in, output impedance, G out. Okay? So I think you're able to do it. They already given to you everything here. In order to calculate this thing here, GM, just formula, and the voltage gain. Okay? And input impedance, output impedance. Now, in general, you know input impedance, right? What input impedance?
1 megohm,
1 megaohm, correct. What output impedance?
RD in parallel with RL.
Perfect. Okay? That means output impedance will be 1.5K parallel RL 10K. So you say that is very simple, right? After you understand it, not a big deal. This just a example. Okay, let's see the difference. And I'm telling you, this also cell bias, cell, you know, strict bias, no, cell bias. Cell bias is not given to you. Graphic, that's why they given to you. Yeah, they given to you ID, okay, 1.95 milliamp. So you can calculate the VS easy. ID,
Well,
IS,
VS is ID.
right. ID, IS will be the same for JFET. Okay. Now come for common source amplified circuit. They give an IDSS VGS of NID. Now they want to calculate the VGS Q, VD, VS, GM0, GM, input impedance, output impedance, voltage gain, and Vout. Okay? I think they already solved it for you. A, B, C, D, E, F, G, H, I. Okay? They already calculate everything. You try to exercise that, try to do. Can you get the same answer or not? The next one, common drain. Okay? This is a common drain. Now, how do we know? Looking into the circuitry, you can see where V in applied, where is the V out. So, you can see a V in here applied to the gate, and V out will be coming from the source. See that? That is common drain. If you're looking into the circuitry, amplify in JFET, and you cannot recognize common source or common drain or common gate, then you cannot do anything. Again, looking into the circuitry JFET, you have to know they will be a fixed bias, or they can be a cell bias, or they can be a voltage divider bias. Okay? What I'm repeating, that makes sure minimum thing requirement. And now we're looking for common drain. What are input impedance? And what is the output impedance?
The input impedance is RG.
You're talking about input impedance.
Yeah, it's RG.
Yeah.
And the output impedance is you short out the C2, so the output impedance is RS.
Okay, we'll see. Yeah. Now,
That's what the load, though. Before
right.
you didn't have a
Now they're
load.
adding the load.
Yeah, you added the load. If you're looking for the output impedance, then it's RS in parallel with RL with C2 and shorted.
Oh, perfect. Okay. So what I want, when you're looking into the amplified effect, you must be recognize common source or common drain. Minimum thing. You have to know. I'm not talking about any calculation. I'm talking about what type of the DC. Is it fixed bias, cell bias, or voltage divider bias? You're able to answer that question. In this case, there will be a cell bias. Okay? And what is the V in and the V out? What is the input impedance, output impedance? Okay? In here, they given you the formula. Voltage gain V out divide V in. V out equal, okay, ID times RS. The gain ID times RS divide VGS plus ID times RS. And ID equal GM times VGS AV voltage gain GM times VGS times RS divide VGS plus GM VGS times RS. Okay, and AV, okay, equal GM times RS divide 1 plus GM times RS. If you need the calculation, you can use that formula. Okay. And now they draw the AC equivalent. Okay. That means you get the gate here, you get the drain in here. Okay. And this is the source in here. Okay. We don't care about that thing here. And they already telling you here. If you want the input impedance, they will be equal RG. And if you want the output impedance, they will be RD parallel RS, but we're not using RD anymore. RS parallel 1 over GM. And this is the gain for common drain. They will be equal GM times RS divide 1 plus GM times RS. Again, they're telling you they don't care about this thing. Internal resistor. Okay? And this is a common. Okay? Example. Common drain. So, this is a VGS. Okay? This is a V out. Okay? And you get RF here. So, determine G out for the network. Okay? Yeah, G out. Let's see. In here, I/O, current output equal IRS minus GM times VGS. This is the GM times VGS. Okay. IRS. Okay. They go this way, opposite to VGM, VGS. Okay. So they can calculate the I out equal V out divide to I out. Okay? And they will be equal 1 divide 1 over RS plus 1 over 1 GM. Okay? However, this is the formula they given to you if you want to calculate it. And also, for output impedance equal RF parallel 1 over GM. Also, they already said we don't care that. Okay? So basically, if you know about the JFET, I believe you're able to calculate it. Now, this one. When I'm looking into that, I know that will be a common drain. Okay? And they given you VGSQ, IDQ. Okay? So that's easier to calculate. They calculate GM0, GM, input impedance, output impedance, AV. G in here, G out here. Okay? Then if you go to previous page, and I think can help you to do it. Now, this is a summarize a little more common drain. The circuit below here, common drain amplified, usually referred to as a source follower. Okay. Remember, common drain, another way is source follower. A source follower has a high input impedance, low output. Okay. A source follower has a high input impedance, low output impedance, and a voltage gain less than 1. That is especially for common drain amplifier. Okay? So now on this one, when you're looking into this circuitry, you must telling me this is a common drain or source follower. Okay, amplifier. That's very simple, very easy. Okay. And now they can give you the same simple circuitry. You get the input, okay, that RL, okay, and they given to you the formula how to calculate the GM0, 1 minus VGS over VGS off. And also they given you the formula AV, okay? Remember, don't care about that. If you want the gain, they will be GM times RF divide 1 plus GM times RF. Okay. If you want to calculate the RF, okay, RF parallel with RL. This is the RF right here. Man. RS here, RL here. Okay, the parallel. And what type DC for the circuitry? Cell bias, switch bias, voltage divider bias.
Self.
What they will be?
Self.
Cell bias. You can see that when cell bias, you want to do, you have to get a graphic, but never. So that's why they given to you Vs equal to 2 volt. All right. If you get Vs, then you can calculate the IS. IS and ID equal. So that's why you can get the ID. Okay. So in here, they already given to you. Easy to calculate the IDQ, VGSQ, VD, okay, GM0, GM, input impedance, output impedance, and voltage gain. Everything they already given to you. Only thing is, you don't have to remember the formula. Normally they given to you, but how can we using to calculate it? Last one, common gate. Remember, gate here, drain here, and the source here.
Hey, Mr. Pham, where's the DC one for the gate? This is for the AC.
For the gate,
Yeah, where's the DC schematic for the gate? This is the AC.
this is the AC
I
drawing.
know, but where is the DC schematic?
Oh, that is common gate. Okay. Right here.
This is the AC schematic. Where's the DC?
Yeah, that's right now, that DC, but still here. You see that? You still get the VDD here. Let's see. The input is on the source, output is on the drain. Okay, this is the output here, VDD.
I
Right?
know, but what I'm having a problem seeing is on these mostly you've shown like the DC one first and then the AC second. So this has got a AC signal on it. So where's the DC schematic?
Oh, they don't have a DC schematic? Uh,
Can you draw it real quick next to this, maybe in a small portion?
no, let's see.
What was that it?
That's what I'm looking for.
Yeah, go down.
Uh-huh. So basically, this is the, let's see. This
Go
is the
down, Mr. Pham, go down.
going down.
One screen. No, the other way, the other way. Hold it. Whoa, right there.
Yep,
Is that, yeah, is that it right there?
let's
The,
see.
the
Right.
gate, the
You
gate
see
is,
right here.
okay, that's the DC one, right?
Right.
Okay, that's what I wanted to see. Because normally you do the DC first, then the
Right.
AC second.
The thing is you already learned DC.
I know, I always see this, the common emitter and the, or source or whatever, depending on which transistor we're talking about, but the gate, sometime I don't see that. So that's why I asked.
Okay.
Okay, but go ahead, Mr.
Yeah.
Pham. I know where it's at now.
And now this is our amplifier common gate input here. Okay. And the output will be here. Okay. And they telling you they want ID Q, VGS Q, VDGM0GM, G in, G out, on the gate. And basically, that also cell bias. So that's why they have to give it to you right here. Okay.
So for the common gate, then the input impedance is low then, right? Only 200 ohms?
Input impedance. Okay.
Right. Where RS is at? That resistor RS, that's
You
the same.
see that here. G in
Yeah, yeah, that's ZN.
equal RS parallel 1 over GM. That is the formula to
Right. So
calculate.
ZN, so for the common gate, then ZN has a low input impedance. Is that correct?
Right.
All right, thank you.
Okay. So basically, you cannot say you're looking into here and say 200 ohm. No. They will be RS parallel 1 over GM. Okay. G out equal RD here parallel with load, and the gain equal GM time RD parallel RL. So that's a little more simple than common drain. Okay. So next meeting, I will be talking about the mode. Okay. And CMOS amplifier. Okay. And you understand the next week will be the last week for the fall 2025. In the on schematic, on calendar, I believe January have to be take one for fall 2025. When we go into February, they start on 2026. However, they change. Okay, so we get one more week next week for fall 25, and after that will be for spring 2026. So anyway, the next week I coming in up there in the class, try to clean it up. Okay, try to see how your guy can be registered.
So you're going to do the registration on Monday?
Right, next week.
Okay.
And
And then, and then another thing, because I usually come to both of the classes. So what about Tech 2?
same thing.
Registration on Monday? And
Right.
are you going to do Zoom or in class next week for Tech 2?
Next week schedule will be Zoom on Friday.
Okay. What about tomorrow?
Tomorrow, no,
Tomorrow's Friday. So what about this?
nothing.
Are you coming to the class on Friday or Zoom
Zoom
for Tech 2?
schedule next Friday.
Oh, next Friday.
Yeah, that's the one, for the schedule. Okay, now is the different.
Okay. All right. Thank you.
Schedule I will be next week talking about the memory lab 6116.
And that's in class.
Right.
Okay. Got it.
The thing is the one I given to you, the memory 2114, that I already given everything, and that will be a very simple lab.
Yeah, that's the easy one. The
Exactly.
6116 is next week.
That's the problem.
Okay. Got you. Got you.
What I want you guys on schedule to do when you get the run the test, it failed. How can we using the debugger software to fix the problem?
We call Mr. Pham.
Okay, any question, anything? No?
Okay. Have a
No.
good weekend, Mr. Pham. Have a good weekend.
You too. Okay?
All right, take care.
Okay, so we'll see you on Monday.
Okay.
Bye.